Hello and welcome back. Let us try to recap a little bit of matrix concepts here because we are going to learn eigenvectors and eigenvalues and singular value decomposition in our next session. So having a little bit idea on matrices is good. So let us recap for maybe 2-3 minutes. Diagonal matrix and identity matrix. Now if a square matrix where all off diagonal values are 0, then we call it as diagonal matrix. If you look at this, all off diagonal values are 0, even this matrix or this matrix, only diagonal values are there. Okay, in eigenvalues, eigenvectors, you will get a eigenvalues matrix, a diagonal matrix. So because of that reason, I am trying to recap that here. So here the diagonal values are non-zero and all the off diagonal values are 0. That is called as diagonal matrix. Identity matrix, a square matrix with diagonal values 1 and off diagonal values is 0 is called a square matrix. If you look at this definition, identity matrix is a diagonal matrix with 1 as diagonal values. A diagonal matrix means off diagonal values are 0 and diagonal values have values, but in identity matrix the diagonal values are going to be 1. What is the speciality of identity matrix? When you multiply any matrix with identity matrix or the identity matrix with any matrix, you will get A, right? The same matrix. A into I is equal to I into A is equal to A. That's the speciality. It is like 1 in normal numbers. Identity matrix is a one kind of matrix in normal numbers for matrices. Okay, and then we'll try to understand inverse of a matrix. Okay, so I have taken simple 2 by 2 matrix. We just need to understand what is inverse. That's it. No need to be a professor in mathematics to understand machine learning. So to A, B, C, D is a matrix. If you take a square matrix, a 2 by 2 matrix, and the inverse of that matrix can be calculated like this: 1 by AD minus BC, right? These two values multiplied with these two values and subtracted one from other, and then D minus B minus CA, shuffle them a little bit. That's going to be a 2 by 2 matrix. If you take 8, 3, 5, 1, if you have to calculate A inverse, you need to calculate 1 by AD minus BC. AD minus BC is called as the determinant of the matrix. Okay, so we'll use all these terms and terminology in eigenvalues and eigenvectors and singular value decomposition. So I am recapping that because of that reason. Okay, so here A inverse is equal to 1 by AD minus BC into the D minus B minus CA. What is D? 1. The minus B is 3, applied minus C, and A is 8. And you got the inverse of the matrix. When you multiply A into A inverse, you will get I. When you multiply the matrix and its inverse, right, you will get identity matrix. Okay, so some matrices will not have inverse. Those kinds of matrices are called as a singular matrix. The matrix with 0 determinant is called a singular matrix. Sometimes we have seen that in normal equation. When we understood normal equation in linear algebra, if you have two strongly correlated columns or linearly dependent columns, right, when you try to create inverse of that matrix, when you multiply the matrix with itself, it will create a singular matrix and you cannot calculate inverse of it. So there are some matrices where determinant is equal to 0. For those matrices you cannot calculate inverse. This concept is also useful in eigenvalues, eigenvectors. We'll encounter it again. Okay, for that reason I am explaining it. A singular matrix has got a 0 determinant. Okay, so if you look at this matrix, right, you calculate determinant, it is going to be 0. You cannot calculate inverse because it is going to give you divide by 0 error, right? 5 divided by 0, 5 divided by kind of that, right? So that is inverse of a matrix. And then symmetric matrix. When you transpose a matrix, you will get the same matrix. That is called a symmetric matrix. In a symmetric matrix, these values are going to be same. If you see, upper triangular and lower triangular values are same. You don't care about diagonal here, right? Only upper triangular and lower triangular values are same. When you transpose it, you will get the same matrix. Transposing means making rows as columns and columns as rows. Even if you transpose this matrix, right, it's going to give you the same matrix. That is called as symmetric matrix. And if you take a distance matrix, if you have 4 cities and you have created a matrix of distances between those 4 cities, city 1, city 2, city 3, city 4, and columns also city 1, city 2, city 3, city 4. and city 1 to city 1 distance is 0. City 2 to city 2 is distance 0. So diagonal values are going to be 0, but upper triangular and lower triangle values are going to be same, right? So like that, distances between two multiple cities can be a symmetric matrix. Okay. So the other example is correlation matrix. If you have features, n number of features, right? Here 5 features I have taken. If you calculate correlation between them, right, the upper triangular and lower triangular values are going to be same. So it's a symmetric matrix. That is just a recap of the matrix concept. Thank you.